Okay, what we want to pay attention to at the beginning here is in the word problem. This problem only exists in between 0 and 8. And also it gives us the position of particle P, but the velocity of particle Q. So when it says, when is the particle moving to the left? If something's moving to the right, velocity is positive. Something's going to the left, the velocity's got to be negative. So you got to find the velocity of this. This is your position of particle P. You got to find the velocity function, right? Which means you got to take the derivative of that thing. So remember, you do the derivative ln of something, you go 1 over that stuff, times it by the derivative of that stuff. And then if you set that less than 0, because you're trying to figure out when the velocity is negative, this is a review of a nonlinear inequality. This is your number line thing, right? Anytime you have a nonlinear inequality, do your number line thing where you get the zeros for the top and the bottom. So if you set the top equals 0, we're going to get t equals 1. When I go to set that bottom equals 0, realize it's never equal to 0. If you do the opposite of b over 2a, so if you do 2 divided by 2 times 1, you're going to get 1 for the x coordinate for your vertex. If you plug that back in, you're going to get the vertex as 1, 9. And then your parabola opens upward because your a is positive. So if the parabola opens upward and starts at 1, 9, it doesn't cross the x-axis at all. It doesn't have any zeros. Also, if you go do the quadratic formula or completing the square, you're going to get a negative underneath that radical, which tells you that bottom part has no solutions. But if you did get a couple numbers from that bottom part, you would put those on the number line as well. But then, so you got 1 is the only number you got to check, and you got to check something to the left and to the right. So if I plug in 0 for all the t's, I get negative 2 over 10, which is a negative number. If I plug in 2 for all the t's, I get 4 minus 2, I get 2 on the top, I get a positive number up top, and I get 4 minus 4, which is 0 plus 10, I get a positive number on the bottom. So positive by positive gives me a positive. And if it says when the particle moving to the right, you're talking in between 0 and 8. When is the particle moving to the left, you're talking in between the 0 and the 1 right there. And then I just kind of jotted down for myself that, hey, we're going to the right in between 1 and 8. Now, part B says, which times is the particle traveling in the same direction? So the two different particles, when are they going in the same direction? Now, I already know here from part A when particle P is moving to the left and to the right, but I don't know where particle Q is moving to the left and to the right. Now, this is an actually easier problem for particle Q. So I'm gonna take that one, I'm going to figure out where it's equal to 0 first. And then I want to do my number line thing to figure out where it's above, where it's positive, negative, where it's greater than 0, where it's less than 0. So do your number line thing, set it equal to 0, find a couple of zeros, put those on the number line, and then plug in test points. All right, so if I use 0, 0 minus 3 is negative, 0 minus 5 is negative. So a negative times a negative is going to give me a positive. There are no even exponents, there are no double roots, which means your signs will alternate right there, or you could plug in 4, or you could plug in 6, and figure out what those signs are. Now that means wherever this velocity is positive, that's where particle Q is moving to the right. So I jotted down where particle Q is moving to the right in between 0 and 3, and then at 5 and 8, and then particle moving to the left in between 3 and 5. Again, you're not going to infinity and negative infinity because it just says in between 0 and 8. So you do your normal stuff, just instead of using the infinities, start at the 0, stop it at the 8 right there. So that's not all they asked for, though. They said, when are the two particles moving in the same direction? So what helped me out, now I know I got some different colors here and it just looks neater, but if I don't have the different colors, I can use a line and some squiggles or something, right? So I made a solid number line here. And then what I did for particle P, I have that in pink here. Particle P, I did the left was the squiggle. So in between 0 and 1, that particle is moving to the left. And then in between 1 and 8, that velocity is positive right there. So that particle is moving to the right. So like I said, if you don't have the different colors, you can use squiggles and a solid line. That was just for P though, for the pink. And then the particle Q I did in blue. And then I said, where it's moving to the left, that was in between 3 and 5, where the squiggles are at. And in between 0 and 3, and then 5 and 8 was it moving to the right. So I put the lines. And same direction means you want to know where are the squiggles overlapping? Like if the squiggles are on the same spot, that would be my answer. Or if the line part is in the same spot, that would be my answer. So the squiggles don't ever overlap. So it's never moving to the left at the same time, but the line part overlaps. So that means they're moving to the right at the same time in between 1 and 3, and they're also moving to the right in between 5 and 8. Letter C says, find the acceleration of particle Q. I like particle Q because particle Q is our easy polynomial. You know it goes position, velocity, acceleration. So if I want the acceleration, I got to do the derivative of that. So I started with the velocity, did an easy derivative, and then they said at t equals 2. So there's my acceleration at t equals 2. Keep reading. Make sure you read all the problem and answer all parts of it. And then it's asking us our question that we're used to. We've seen this a bunch. Is the speed of the particle of particle q increasing, decreasing, or neither at time t equals 2? Now remember, speed is increasing if velocity and acceleration have the same sign. Speed is decreasing if velocity and acceleration have opposite signs. We just calculated that the acceleration is a -4. So then I needed to figure out what the velocity was. So I took the 2, plugged into my velocity function that they gave us, got a 3, practice all that without the calculator. And then I said the speed of the particle q is decreasing since the velocity and acceleration have opposite signs. One was positive, one was negative right there. But that's your justification from your blue sheet that we keep seeing all over the place. On letter D, when you see this word position, I want you to remember you always got to take into account the initial position. And that's why you just kind of read the problem at the beginning. It says at t equals 0, that position is x equals 5. So you got to start with the 5. This is at t equals 0. That's our position right there. At x is going to be 5. And then when you integrate the velocity, that'll get you the position. This will tell you, and then this is where you're at t equals 0. So you pick it up right where you left off. You integrate between 0 and 3. So this expression, when you integrate the velocity, we know that gives us position, but that just tells you where did you go in between 0 and 3. And then this tells you where you're at 0 to begin with. Now, if they would have told us that t equals 2, we're at 5. Well, I still put a 5 right there, but then if I was there at t equals 2, then I'll pick it up where I left off. I would start that at 2 seconds and then go to 3. But it says at t equals 0, we're at 5. So I started there and then pick it up at 0, go to 3 right there. So anytime they got a position, take into account that initial position, and then you had to just do that without the calculator. But you're all smart. You can do that easy integral without the calculator. You did a lot harder integrals than that guy right there. So just be really careful with your arithmetic on the basic stuffs right there and get that 23. And then just in case that helps at all, I just kind of jotted down what I talked about right here. If it tells me to find the position at 3, I did the position at 0, the starting point, and then I picked up where I left off. So those numbers will always match, and then you integrate it to where you want to go there. Band.